Hello everyone, welcome to Gangs of PCM. This is Priyanshu, and together we are going to solve all your physics related worries. The question we are going to solve today is from JEE Mains exam, which was held in January of 2020. This question is from chapter Gravitation, and to solve this question we need to know about the orbital velocity concept, conservation of mechanical energy concept, and velocity of center of mass. So these concepts are necessary if you want to solve this question. Now let's start to solve this question. So solution. Let's take the first case. The first case would be when object is just fired. When a satellite is just fired from surface of Earth. From surface of Earth. So what would be the diagram in this case? So this is your Earth. Radius of Earth is RE and the mass is ME. So there is an object over here. This is your object. And this object is fired with velocity U. So in such case, what would be your kinetic energy? Kinetic energy in the first case would be how much? Half mv square. What would be the potential energy in this case? In the first case, it would be minus gmem upon r, gravitational potential energy. Now, what about mechanical energy? Mechanical energy at position 1 would be sum of kinetic energy at 1 plus potential energy at 1. This would be equals to half mv square minus gmem by r. So this is, let's say this is your first equation of mechanical energy. First equation of mechanical energy, or like mechanical energy at the first position. Now let's talk about the second case. What is the second case? Second case says that when your satellite has reached height h, and here h is equals to r. Okay, so if we draw the diagram for this, what kind of diagram we will get? Again, let's draw the diagram. So this is your Earth, radius r. We have reached at what height? At height h, which is equals to r. Okay, and at this position, your particle has velocity, let us assume v. At this particular position, velocity is v. So what would be the kinetic energy at this position? Case 2, half mv squared. And what about potential energy of case 2? Potential energy would be minus gmem upon r plus h. So here h is equals to r, so it would become minus gmem by 2r. Okay. Similarly, we'll have mechanical energy at position 2 as summation of kinetic energy and potential energy, which will give you half mv square minus gmem by 2r. So this is the mechanical energy at the second position. Okay, now since no non-conservative force is present, a very important part, no non-conservative force is present. That means there is no force which would cause energy loss to occur. So what would happen because of this? So then your mechanical energy would be conserved, or we can say mechanical energy at 1 should be equals to mechanical energy at 2. So if we from first and second equation, we'll get what? Half mu square minus gmem by r should be equals to half mv square minus gmem by 2r. So see from here, m and m will get cancelled. Let's multiply this entire equation with 2. What you will get from here, we'll have u square minus 2 times gme by r. Send this over here, we'll have plus gme by r is equals to v square, or we can say v square is equals to u square minus gme by r, or also we can say v is equals to u square minus gme by r. This will be the velocity at height h, and this is also the case before separation of rocket. Okay, So I hope at this point, till this point, everyone is clear and everyone is able to follow with me. Okay. Now let's talk about just before separation. Not before, just after separation. So let's talk about case 3. What is our case 3? Just after separation of rocket. Separation of rocket. Just after your rocket is separated from the satellite, what would happen to our system? Okay. So we are saying, let us assume that mass of the remaining part is m dash, which would be your what? 9m by 10, because mass of the rocket, and the mass of the rocket mr is given as m by 10. This is given in the question. Total mass is m, so if mr is m by 10, the remaining part would be 9m by 10. Let's say, see over what is happening over here. We are saying that once the rocket released from the orbit, or at this position, once the rocket is released, the m dash would be moving tangential to the orbit. Why? Because it has become a satellite. It has become the satellite of Earth. Okay, so it would be tangential to the orbit. Let's say the velocity is v naught. So we are saying v naught is what? Velocity of v naught is velocity of remaining satellite. Remaining satellite. And similarly, we can say vr is velocity of rocket, which is separated from your main satellite. Okay, now what is actually happening over here? Let's pay attention. What's happening over here? See, this is the original satellite, and this was moving with v velocity, and at this instant, just at this instant, it is separated into two parts. One is your rocket, another is your satellite, or remaining part of the satellite. Remaining part. Okay, now since no external force, this separation has happened due to internal forces. The separation has happened due to internal forces. That means what? The center of mass, velocity of center of mass would be equals to v only. Even after separation, the velocity of the center of mass would remain as it was before separation. So we can say from here, using the concept of center of mass, we'll have VCM is equals to m by 10 into VR, velocity of rocket, plus 9m by 10 into velocity or orbital velocity divided by m. So we'll have m and m can get cancelled. 10 will go on the left side, so we'll have 10 VCM is equals to VR plus 9 V naught. So other equation which you get from here is VR is equals to 10 times V. Now VCM is equals to V. So 10 times V minus 9 V naught. So this is the vector equation which we get for your velocity of rocket. Now if this is the vector equation, then what would be the magnitude? Square of the magnitude of the velocity of rocket, that would be 10 V square, or 10 square V square plus 9 square V naught square. Okay, now we have already calculated V is how much? U square, or V square is equals to U square minus GM by R. Okay, plus 9 square would be 81. V naught is the orbital velocity. So orbital velocity is given to us as what? Minus, or not minus, sorry, GM by R plus H. Here H is equals to R, so we'll have V naught is equals to root of GM by 2R. So this is your V naught. Okay, so let's put the value over here. So we'll have GM by 2R. Okay, this would give you what? VR square. Okay, if we just rearrange it, what we'll have? We'll have 100 U square minus 100 GM by R plus 81 by 2 GM by R. Take the reciprocal for this, we'll have 200 plus 81 minus 200 plus 81. So we should give you 100 U square minus 119 GM by 2R. Okay, so this would be the velocity of the rocket, which can also be further written as Vr square is equals to, take 100 as common, you will have U square minus 119 by 100 gm by, or what should I say, rather than 100 we say 200 r. Okay, so this is your velocity of rocket. Now we need to find kinetic energy. Question is asking for kinetic energy of the rocket. So kinetic energy would be what? Half mass of the rocket into velocity of the rocket whole square. So let's put the value. So we'll have m into mr is m by 10 into 100 u square minus 119 upon 200 gm by r. Okay, let's solve this. We'll have from here 5m u square minus 119 upon 200 gm by r. So this is the kinetic energy of rocket just after separation. Just after separation. This is your answer. Now if you look at the options, we can see your option B is correct. Option B. So we have solved the question which was asked in your JEE Mains examination. Okay, so I hope you were able to learn something from this video, and if you are able to learn something, and if you find these videos interesting, please coming back and subscribe to our channel. Thank you. Bye bye.